So last time we started talking about bivariate data, which has explanatory variables and response variables. One thing controls the other, or we at least think it might. And what you're going to be doing now is you're going to be looking at a bunch of scatter plots and deciding whether or not the association between the different variables, whether there's a connection or not. Do you think there's going to be a connection? And whether or not you expect that connection to be a positive connection or a negative connection. All right. So what I've got there up on behind me are some questions that says, for each of the following, decide whether you think there would be a positive or negative association between the variables, or none at all, or there's absolutely nothing at all. All right. So for each of the following variables, indicate whether you would expect there to be an association and if it's positive or negative. So do you expect someone's fitness level to be connected to the amount of daily exercise? Is that something that you think is a reasonable association to make? All right, now, would that be a positive association or a negative association? All right, it's going to be a positive association. So the next thing I'm going to ask you is it which is the response and which is the explanatory? Which thing controls the other thing? Which thing controls the other thing? All right, think about it logically. If you want to improve your fitness level, you're going to have to increase the amount of daily exercise. All right, so your exercise will control your fitness level. Yeah, fitness level is your result. Now, just because one thing doesn't control the other thing doesn't mean there can't be some sort of connection between them. For foot length and your height, is there going to be an association between them? Okay, there is going to be an association. Now, it might be hard to decide which one controls which thing, but if you were to scatter plot it out, you would see that there would be a relationship between foot length and height. Generally, the taller you are, the bigger your feet are going to be. All right, so I am 184 centimeters, and I wear size 15 shoes. But someone who is 180 might need 14s, or they might need 15s, or they might need 16s. But there is going to be an association between a person's foot length and their height. Now, the next one here, comfort level and temperature above 30 degrees. Would you expect that to be a positive or negative association? Because what happens as the temperature increases? You start to get, how do you feel? Yeah, sweaty. And if you're sweaty, would you say you're comfortable? No. So your temperature graph would probably look something like that. So you would start up here, and your association would be down. So it would be a negative association. Now, here's where we start to get to some of the ones that are like completely silly. Foot length and intelligence. Now, clearly I'm the exception because I have very big feet and a very big brain. But is that something that you can generally say? Are all people with big feet very smart? No. And does that mean all people with small feet are stupid? Or it could be the other way around. It could be small feet, big brain. Who knows? Point is that there is no association. You cannot reasonably make an association between the two. The next two are interesting in that it's really dependent on a couple of other factors. The time you take to get to school and the distance you travel. Now, generally, how would you expect that relationship to work? How would you expect that to work? Yeah, the more distance you travel, the longer it's going to take. However, that is also influenced by the mode of transportation. You could have two people both take half an hour to get to school, but one drives from 30 kilometers away, the other one walks from 10 kilometers away. Point is that you can't make that big of an association because there's a third factor sitting outside of it all that's affecting things. All right. Now, I would say that yes, there is a positive association between it. The further away you are from school, the longer it's going to take. That's fair enough. But there's a third factor that goes on, and we're going to talk about that in some of the later chapters. And then the number of pages in a book and its price. Would you expect that to be a positive or negative association? Would you expect the number of pages in a book to influence the price? Because I can think of some very short books that are very expensive. I can think of some very, very big, thick books that you could probably buy for $1. All right? The genre of the book, whether the book is a hardcover or not, those are all other factors that play into it. All right? You cannot make an association between, I could have a 2,000-page book, probably only cost me $10 because I wrote it. It's going to be garbage. All right? So you have to use a bit of logic to think about the problem and say, is there a connection here? Is there going to be a connection here? And sometimes there is, and sometimes there isn't. All right? So let me get the next question up here on the board. All right, and here is your next set of problems. What I have here are some basic scatter plots. All right, and these scatter plots have associations with each other. Now, looking at these pictures, the first one up here is linking the time studied with their mark in terms of hours. Would you describe that as a positive or negative relationship? So the one at the top, would you describe it as a positive or negative relationship? All right. Now, it is positive. It is positive because we are going from the 0 and we're moving to the right and up, to the right and up, to the right and up, to the right and up. All right. It is a positive gradient. If we were to imagine a straight line connecting it, it's going to be positive. Now, sometimes on a scatter plot, what you might notice is that there is an outlier. All right. Which dot, or what would you say, what's the value of the point that you would think is a bit unlike the others? All right. Roughly how many hours and mark percentage did that dot point get? Yeah. So the person who got 36 hours and 35 marks, so the one in the top right-hand corner, it's a bit unlike all the others. It's probably an outlier. All right. And sometimes when you go through these, again, just like when you had to do box plots, sometimes you'll have to pluck out the outliers and say, I don't need that. All right. Now, moving to the next one down. Oh, before I continue, would you describe the relationship in A as being strong, moderate, or weak? All right. Strong, moderate, or weak? Moderate? You reckon? Why do you say moderate? Why do you say strong? All right. You're going to be asked these questions, and it's up to you to decide, well, is it strong? Is it weak? And you're going to be expected to justify why you believe that. All right. All right. Look, I would say strong because if you look at the cluster down the bottom there, everything's pretty tightly packed together. If you were to imagine a straight line connecting, everything's pretty close to the line. All right. Now, if you said moderate, I would also be pretty prepared to accept moderate at this point because, again, if you connect the line from the person who studied for an hour and got 21, I give them a name, Sal, and then you got the person at the top end who got 35, 36, and so studied for 36 hours and got 80 something on it. Might call them, don't know, can't think of a person who would like to call them that. You can see that they're not far off the line, but they're also not on the line. All right. Now we're going to have it. There's going to be a mathematical way to determine whether something is strong, medium, or weak. But it takes the next chapter to do that. All right. Moving on to the next one. Would you describe that as being positive or negative association? Yeah, it's negative. So over time, everything's decreasing. And would you say that is strong, weak, or negative? Oh, so strong, weak, or moderate? I don't know. I'm more inclined to go with strong on this one. But again, if you were saying moderate, I'm pretty flexible with that. They're pretty much together. So I would say it's a strong. All right, and then the last one, the relationship between the mother's height and the daughter's height. It's weak. It is definitely weak. There is no doubt about it. This is a weak association, but it is definitely, there is an association there, and it is definitely weak. All right. So we've got strong positive, strong negative, and we've got a weak positive as well. All right. So the questions from 7C are relating to these sort of graphs. There's only a couple there. It takes you about 3 seconds to go through them all. We've gone through most of them already. So it'll be your job to finish those off. However, what we've got next is a mathematical way to determine if something is connected. All right? And what we have is we have a lovely table that links two things, and that requires us to do a bit of calculations. All right, so I'm going to get a table of values up here, and you guys, I would strongly suggest that this goes into whatever notebook or cheat sheet you guys are using, because this is very, very important. All right, I'm not just saying that for my own benefit, I'm saying it for yours as well. All right. All right, so this table here, Pearson's correlation coefficient, also known as R, is used to classify the strength of a linear association. All right, and that requires, one, there to be a linear association, and for there to be for the data to be numerical, to make that connection. Now, we use that to sort of determine how far apart everything is spread from a center line. And you guys will be given an equation to calculate what R is, and then that will tell you which row of the table it fits in. All right? If I happen to get a value of R that is 0.3, then it's probably a weak positive. All right? Now, to calculate it, we need a an equation. We need to estimate it, all right? And the way we estimate it is by looking at some previous ones that are already made. So I've got some examples here of the sort of things that show up as correlation coefficient graphs. And what we're going to do is have a look. So these graphs here are just some data sets and what their correlation coefficients look like. All right. So what you can do is you can look at, so for example, the first one, the top left corner, R equals 0.915. Now, based on what that previous table says, what would you classify that as being? All right. If the answer is 0.915, look at that previous table. What does it say? All right. I'll get that table up there for you as well. All right. So there, 0.915 shows up in dark blue at the top. It is a strong positive. What about the others? So along the top, there, what does it say? What sort of values do we have? So the first one is strong positive. I'm in agreement with you on that. But what about the others? Yep. 2 is strong positive. It's not as strong as the first one. In fact, it is actually awfully close to being moderate positive, but it still fits in that strong positive category. And the last one is 0.551. Where does that sit? All right. It is still moderate. It's very, very close to being weak, but it is still moderate. All right, 0.551 is just above the bottom end of moderate. All right, looking at the other three. Negative 0.874. Negative 0.874. It's a very, very strong negative response. The next one would be a moderate negative response. And for the last one, would you say there's an association there at all? Would you say there's even an association at all? It's just a bunch of dots all over the place. Some things happen to line up, but if you look at the entire data set, nothing. All right, doesn't make any sense. No, it is 0.15. Which is in that no linear association between negative 0.24 and 0.24. If you said it was weak on a SAT, you would be wrong. All right? Because I can't even tell where I'm supposed to start drawing my line. Because I could reasonably draw from the bottom left to the top right, or I could start drawing from the top right down to the bottom left. Or, sorry, top left to bottom right. All right? You could reasonably draw your lines in either place, and you wouldn't know which is real. All right? Now, there is some very interesting things that happen when you start to play with the correlation coefficient and you start to look at them. All right. So what if I were to say that there was something that had a 0.95 correlation coefficient? All right. It had a correlation coefficient of 0.95. A correlation coefficient of 0.95, what would that show up as on the table? What would it show up as if you're looking at it on the table? .95 on the table. What does that come out as? All right, there's the table there. All right, 0.95. A strong positive linear association, 0.95. Strong positive, very strong positive. It turns out that if you were to correlate, as in you do a scatter plot of the amount of cheese someone eats and the number of people that die in their bed sheets when they get tangled up, you would turn out there is a strong correlation of 0.95. So there are some things that, if you were to scatter plot them, would have extremely strong linear relationships. Does that mean that if you eat cheese, you'll die in your sleep? Because the scatter plot seems to suggest that eating cheese means you're more likely to die strangled by your bed sheets. Does that make sense? Does it even make... No, it makes absolutely no sense. It is a coincidence. All right? They just happen to be linked together. All right? So it is entirely possible for some things to be linked together through a scatter plot, but actually have nothing to do with each other. All right? And that's part of what you're going to have to do when you look at 7D. All right?